Hello everyone, we are Federico
En Calogero.
from Accenture Digital, and today we are here to show you how you can integrate machine learning into iOS application. It all started a few weeks back when I was with my girlfriend and she told me that her favorite flowers are actually tulips. And then I was completely lost because I am a man, I'm a software engineer, and I don't know anything about flowers. Then I decided to do the only thing that seemed reasonable to me to overcome this issue, that was building a vision and machine learning integrated iOS application to identify flowers. And today we hope that we are going to show you how easy it is with the newest Apple framework to build such an application. And we hope that you will go out of this session and be able to build even more amazing things. As you can see, we have a very simple application that is able to recognize a flower when it sees one and distinguish between different kind of flowers, and then completely solve my situation. But let's take a step back. What is machine learning? Machine learning, if you go into literature, is the science of getting computer to act without being explicitly programmed, which might seem like a complicated definition, and I want to point out that without being explicitly programmed, because I think is a key aspect of machine learning. And I don't want this definition to pull you away from machine learning because it seems complicated, but if you think about it, it's so pervasive that it's used in many, many applications that all of us use every day. We have Netflix that has a recommendation system that will suggest you what to see next based on what you see before. We have Shazam with at its core as a machine learning functionality able to recognize a song from what the phone hears. And finally, we have Snapchat, who use vision and machine learning for the filter that made it so famous. But nowadays, especially before the last few years, almost all the machine learning powered applications were actually just data collector that then send the data to a backend service in which the real machine learning part happens, and then they get sent back some results. But choosing an integrated approach can have significant advantages over a service solution. First and foremost, the privacy, because data never actually leave your device. Then we have the possibility to optimize the machine learning model and prediction for on-device performance. Servers become an actual choice and not an obligation for machine learning powered application, because we can choose to make the machine learning part happen on device or on the backend. And this, for independent developers or small companies, could be a significant advantage. And finally, probably the most important is availability. Now we can use the power of machine learning independently from the network connection. Apple facilitated this process with the introduction of CoreML first, and then this year with the introduction of CoreML 2, and then CreateML, which filled the gap in the production pipeline that would allow us now to start from the data and fully build a functional machine learning application within Xcode. We have to point out that the declared purpose of Apple in this case is to bring machine learning to every iOS developer. So their purpose is to allow each one of us to use machine learning. So apologies to whomever have multiple PhDs in machine learning, because this presentation is sort of high level, but that's the purpose of Apple. It's paving the way for us by hiding implementation details in many cases. Of course, we need to point out as well limitation of having an integrated solution powered by the Apple framework, because the biggest drawback is definitely the model update, because there's no support for model retraining on device, which means that the model cannot learn from the data that he sees or uses, but we need to implement some workaround if we want to achieve that. One issue that was maybe more significant last year, now it's mostly an inconvenience. It's the compatibility, which is iOS 11 and later, and I say an inconvenience at most because iOS 10 has almost negligible market share by now. And finally, the size of the model is an issue because the complicated machine learning models could arrive to weight even hundreds of megabytes, and increasing the package size of a mobile application of hundreds of megabytes is a significant issue. An issue that was tackled with the introduction of quantization with CoreML2 that we will go more in detail later. So to recap, now we have a full pipeline with Unix code that each one of us can use with ease that allow us to start from data and then to the power of CreateML, generate a CoreML model that we can easily integrate in our iOS application. Now my colleague Calogero will show you how to create a model with CreateML.
Thank you, Federico. Hello, everyone. Okay, Apple released CreateML with the latest version of macOS operating system, macOS Mojave, and it's a framework that permits you to train and create from scratch a CoreML machine learning model, even if you don't have any experience in machine learning and artificial intelligence. CreateML leverages the built-in machine learning capabilities that are available on the latest version of the operating system released by Apple. And it permits you to create a very efficient, memory-efficient machine learning models. It comes with 3 built-in trainers, which are able to train models that are able to recognize images classifier, natural language classifier, which are models that are able to extract meaning from natural text, and also tabular data classifier, which are models that are able to extract prediction from an homogeneous set of data. For example, an example of tabular data classifier would be a model that is able to predict the quality of a wine starting from its chemical composition, for example. Our presentation today will focus on the image classifier, which is very interesting from a developer point of view and from a theoretical point of view. But before starting our journey through the capabilities of the image classifier available on CreateML, it's very important to understand what is the workflow that guides the process that permits to create a machine learning model. That workflow is organized into 3 different phases. The first one is the data collection phase, during which the developer must collect a data set that will be used to feed the trainer in the next phase, which is the training phase. During the training phase, CreateML trains the machine learning model, starting from data. And at the end of the training phase, it produces a model that can be immediately integrated into your application. But before integrate the model, we need to evaluate if it fits our requirements. And then I will show you how it's possible to understand the quality of a model. If the model fits our requirements, we can immediately use it. If no, we have to start again the process. We have to retrain the model, maybe choosing a different data set, and starting with a new iteration of training. This is the workflow that guides the creation of a model. Let's start with an example of how to train a flower classifier, which is the topic of our demo. First of all, the developer should collect images of flower. Those images must be organized in folders, like the one you are seeing on the screen. Each folder must be named after the category to which every image belongs to. So we have a folder that contains all the sunflowers photos, tulips, rose, etc. The name of the images is not relevant for the training process, so you can use also random names for images. CreateML supports PNG and also JPEG and the other image format, so you don't have any problem with images. Once you have the data set, you have to start the training. And here is where CreateML shines, because the training process is based on a technique called transfer learning that permits you to obtain a machine learning model in a few minutes of computation, even starting from a very small data set. How is that possible? Because Apple has already learned many information about image recognition and has already trained its own models. Because we use image recognition in many applications, for example, photos or also Siri. So Apple already knows many things about images and is able to recognize images. Thanks to the technique called transfer learning, CreateML enrich the information that arrives from the neural network already built by Apple, which is the one in white in that photo, with the information that arrives from the dataset that we provide. And thanks to that merge, CreateML is able to create a model that is very small in terms of size, some kilobytes or some megabytes, it depends, instead of hundreds of megabytes for a normal model done created with CreateML. And it permits you to build that model with low requirements in terms of computational power. And now I'm going to show you a very simple example of how to train a model that is able to recognize flowers. So I'm going to switch to Xcode. Okay. Sorry. Okay. Now I'm on Xcode 10. I'm going to create a playground. CreateML provides us some very easy to use playground-friendly API. I'm going to, sorry. Okay. Okay, I created a brand new playground. First of all, I need to open my live view section of the playground. I need to import the create ML UI model. Okay. Then we need to instantiate a builder, which is an instance of ML image classifier builder. And then I'm going to invoke on the builder the show in live view method. Okay. If I run the playground like this, suddenly, or quite suddenly, you will see on the right of the screen a user interface that permits you to start the training of your model. You can expand that view. We can configure the trainer with some parameters that I will explain you later. But the simplest thing that you can do is to drag and drop on the drop area and training for the folder that contains all the images that you want to recognize. So I'm going to drag the folder. The trainer immediately starts its work. All the analyzing happens on the GPU. If your Mac supports have a good GPU. It requires just a couple of seconds. Our testing dataset is very small, but at the end it doesn't require a lot of time. Okay, CreateML created the model. You can immediately save it on your disk, but before saving our model, we need to understand how good it is. CreateML already prepared a validation. Our model is 100% valid because during the training process, CreateML create a testing group randomly from the testing images. So it starts the evaluation of the model during its creation. But if we want to train our model, if we want to understand how good is our model, we have to drag and drop again a new folder that contains all the test images that we want to check. CreateML starts the evaluation phase. On the console, you can see how the process works. We see the percentage of completeness of the project, of the process. It requires some seconds. Okay, it's still working. 75%. We are quite done. Okay. At the end, we obtained a model that is pretty good. It has 100% of quality. Our evaluation is 100%. On the console, the framework prints some data that permits you to understand how good is your model. And I will talk about them later. So we have the accuracy of 100%. We have a matrix called the confusion matrix, and also the precision and recall table that are very important to understand how good is your model. On the right, you have a list of all the tested images. For every image, CreateML provides a prediction on the left. On the right, there is the true value of that image. And if you tap on the arrow, you can see the confidence of each prediction. In that case, CoreML understood that this image contained a tulip with 100% of probability. So our model is very good, so we can save it and use it later for the demo of Federico. But this is the simplest approach for creating CoreML models. Apple provide a more professional tool because we also can build script that permits you to automatize the entire process of building a machine learning model. So I'm going to show you how that is possible. First of all, we need to import the CreateML model. Then I'm going to allocate some variables, some URL that points to the path that contains the training folder, the training directory, the test directory, and then the output model. Then I need to allocate parameters object, which is a struct that permits you to configure your trainer. In our example, we want to perform at most 10 iterations of trainings. Then I can use the parameters that I created to initialize the classifier. So, okay. The ML image classifier is an object that takes an input, the training data directory and the parameters object. And then I can I can evaluate the quality of the model built by the classifier thanks to the evaluation method that has one parameter in input, which is the test directory that contains all the images that you want to use to test your model. We can use the evaluation object, which is a ML classifier matrix, for example, to understand what is the quality of the accuracy of the model. For example, we can print the confusion matrix. We can use the data of the confusion matrix to understand how good is our model. If our model is good, we can save it on the disk using the write method of model that takes a parameter, which is the final directory that will contain the model. So if I run the playground, it starts again the training process that we already see in a more user-friendly way, but it's the same process. This is in order to explain you that it's possible to create scripts that permits you to automatize the creation process. Okay, we already, let's come back to our presentation. I mentioned before that it's possible to evaluate the quality of a model, and I mentioned the confusion matrix and also the precision and recall table. Let's start with the precision and recall. This is the mathematical definition of precision and recall. Precision indicates how your model is effective in labeling all the images that you are recognizing in their category. And it depends on false positives. If the number of false positives is 0, so the precision of the model is 100%, so the model is very good. On the other end, we have the recall parameter, which depends on false negatives, and it the recall value demonstrate how effective is the model in finding all the possible occurrences of the images that we need to recognize. I mentioned also the confusion matrix, which is a matrix that has in column the true value that is contained in the image, and on the row, the prediction done by the model. Now we did another example with fruits. We imagine to have a very simple model that is able to recognize apples and oranges. In our experiment, we have 4 apples and 3 oranges. 2 apples have been recognized by our model by apples. The other 2 are recognized as oranges. On the other hand, we have the oranges, 3 oranges. 1 of them has been recognized as an apple, and 2 of them has been recognized as oranges. So let's try to make a simple example. We have our data set. Our model performs the recognition of the fruits. And at the end, we have those values of precision and recall. In case for the apples, we have a precision of 2/3, because starting from 4 apples, at the end, our model recognized only 2 of them as apples, and the other one has been recognized. It recognized an orange as an apple. So our precision is 2/3. For the recall, we have 2 apples recognized as apples, and 2 apples recognized as oranges. So our recall is 2/4. This is an example of how CreateML calculates precision and recall, that are the parameters that you need to evaluate to check if your model is good. Once you understand if your model is good or not, you have to improve the quality of the model. There are many techniques available that can permit you to improve the accuracy. For example, you need to improve the quality of the dataset for increasing its size or its assortment. There is another technique called data augmentation, which means that you have to provide to CreateML images that are cropped, rotated. In that way, the model is able to recognize images that are not perfect, so the final model will be smarter. We can augment the number of iterations, or we also can change the algorithm that has been used to train the model. But all of those techniques are only hints. They doesn't make any recipe. In order to improve your model, you have to fine-tune your training process, because depending on the type of data set, the number, the dimension of the data set, not all of those techniques are really useful. So you have to tune your training process to create something good. Besides CreateML, there are many on the market. There are many other tools that permits you to train your own models. For example, TensorFlow, to recreate, Cafe, and some of them are able to produce, to create immediately a CoreML model. Some of them no. So Apple created a simple Python library, which is CoreML Tools, that is able to translate their models into a CoreML model. So for example, we have TensorFlow to recreate that are able to export directly to CoreML, and other tools like MXNet that requires a conversion step thanks to the CoreML tools provided by Apple. Okay, I ended the journey to CreateML, so I'm going to pass the mic to my colleague Federico. Thank you.
Thank you, Calogero. And now that the hardest part has been done, and I don't say that because I want to be nice to Calogero, but that's because the most difficult part of this process is the actual creation of the model. Once we have a CoreML model, it's a few easy steps away from having our applications. Because once we have the model, we just drag and drop it into our project, just as a resource, and it automatically generates a Swift class or an Objective-C class that has all the methods that you need to make your classification or your prediction, and it also tells you what are the inputs and the outputs of this model. Once you imported the model into your project, you have to import CoreML from where you want to use it, and then you have 2 lines of code and you can use it very easily. At first, you have to instantiate the model with the class out-generated from Xcode, and then you have to ask for a prediction. And at this point, you're able to return the prediction made and the accuracy of this prediction. Be mindful that, for instance, in the case of images that we went through, that image is not an actual UI image or image, but is a CV pixel buffer, so you might need some boilerplate code. In other cases, it depends on the classifier and the input that you need. But before we go into the final demonstration and we show you how to build the actual application, a couple of points that were a big increase in CoreML 2 compared to CoreML 1, because the model size, as we said at the beginning, could be an issue for mobile application, and it's made by 3 main factors: the number of model, of course, the number of weights, and the size of the weights of a model. And Apple tackled almost all of them, I would say, because for the number of models, they increased the flexibility of this model. So in case, for instance, of images, you initially had to put a model for each size of image you wanted to work on. Now you can specify a range. For the number of weights, it's slightly more complicated to tackle directly because there's not something we can do, as Kalodger was saying, a single recipe for all cases. But what they did was introducing an even broader machine learning support, and then we can work with different classifier, different options, and that can have effects on the number of weights of a model. And finally, we have the size of the weights, which has been tackled with quantization. Quantization is mostly a discretization of the values of the weights, because the value of a weight is represented by a continuous value, and of course it requires more memory than a discrete set of values. Therefore, we can approximate the possible values of them with quantization. Of course, as Apple themselves tell us, we have to consider that it is a trade-off between quality and the weight of the model. So depending on the use case of your application, of your model, you can make different choices. And you can do this kind of process through the use of the CoreML tools. One last step that they introduced was to power CoreML for those people who did more advanced applications, or even if there is some breakthrough in the machine learning field, since it's such a fast-growing field, with the introduction of custom layers and custom models that you can implement directly. So now let's go to see how we can integrate our model into our application. So once the model is created, we just drag and drop it into our project. And that is done. As I was saying before, it's imported and it automatically creates the generated class with all the methods that you need to use it. Then what we did was to utilize machine learning with vision. And the way you can do this in iOS application is that Apple introduced a middle layer framework, I would say, that is used as a bridge between vision and machine learning, so that we can power our vision application with machine learning. So we create some code before, which what does, it's basically to handle the vision layer, since we wanted to focus on machine learning here. So what we do is to import CoreML. Then we have to create we have a first step of creating a VN CoreML request. A VN CoreML request is something that we send to this intermediate layer between machine learning and vision that is handled by a request handler. in the vision layer that used to scan the images that it sees and then send us back results when it found something through a callback. So what we do is, in this case, we created one method helper for generating the core ML request in order to be flexible and be able to assign it different models. But what we did in this method was simply to, at first, generate the model. And as you can see here on this line, we are encapsulating into something that can be used in vision as well. And then we just create a core ML request that requires two kinds of things. One is the classifier, which is basically our model, and the other one is a completion handler, the callback that will be called when it identifies something. Inside of this callback, what we can do is we receive and we handle the results. We can filter for the confidence of it in order to filter out results that are not very clear and probably are not a correct prediction, but just something the vision layer retrieves. And then we can have the confidence, and in our case, the identifier, because if we go back to our machine learning model, we say that we have a label containing the identification of our model and the probability of it. So once we have done this step, we just instantiate and create our vision manager, which is the vision layer that we created to handle the relation between vision and machine learning. And one interesting thing to notice is that this layer can handle not a single request, but an array of requests. So this could use to have fallback solutions, to have multiple recognition systems at the same time. And finally, we just have our system to start, and we are ready to run our application. Okay.
Sorry.
And once let's start another way of sharing the phone to you.
Okay.
And now, as you can see, we are able to identify images and get back the first result. But what it actually gives us back is an array with all the possible results that our model is trained to recognize and the single probabilities of each one of the possible cases.